So, welcome everybody. You see we are two of sitting in front here, standing in front of you. So maybe this is, yeah, respecting that we're doing a new project, so we're two guys to bring a new project. Okay, so first of all, I'm Gerhard Glocker, and this is Thomas Jekle, and we are a team of Bosch Software Innovations that brings in a new project. We have no project lead called Kai, but we have at least a committer called Kai, this one. So, but it's UFI Kai, it's not the same spelling, but okay. So maybe we are on a good road on this one also. Okay, so what's our background? We are coming in a DevOps history of in Bosch Software Innovations. And so we're doing a DevOps for a cloud service for 2.5 years already. And this is the foundation of the Eclipse Ditto. And it's the core principles there are challenges about distributed and high scalability. And this is our background where we have. This code base is quite emerged already, and it's battle proven. So it's really doing large projects within the Bosch group with a lot of challenges there. And so it's not a new code base, so it's really extracted from somewhere. Yes, Jens? Large is, so we're dealing about devices. In this case, they are in the automotive area, and they are coming, from, for example, in boxes from cars. And so we have a project with 100,000 boxes there, which sends out updates all the time. The service in the Bosch group is managing about 1 million of devices there already with some differentiation between hot and cold devices. And so it's growing, but it's quite okay at the moment already. Okay, and we're going to go into open source because it's the best model to do this job there. Yeah. Oh, it doesn't work. Take this one. So, what is the metaphor behind? We're talking about digital twins, and we're talking about this because we found out in the Bosch group that it's really simplifying IoT solution developments a lot. You can do classical IoT development without such a metaphor, just by sending messages to a device, getting something from a device. But in the end, it will make it much more simple if you put up this concept of digital twins in between, and then you have it much more easier to do development, especially development in a web-style way that a lot of developers are used to. So not for a classical enterprise developer or a web developer, the metaphor is very helpful because it's really more, they're more used to the models that are behind this. So, of course, there are some aspects of digital twins that are mostly visible. So the first and most obvious point is that it mirrors the physical devices. So this is more a very simple model that you have a device representation in the back end somewhere, which is more or less a mirror of your device out there. So this is of course the foundation, the starting point, but it's not everything. It's not enough, and so. A lot of times, the digital twins bring additional aspects and services around these devices. So a device is not only the state that it brings in, but also additional services, additional aspects that come in. And this is really driven by the industrial IoT discussion a lot, because there you see that devices are much more complex. They are machines in background, and a machine is not only the state of a few properties, so there's much more on it. And this is also an aspect that the digital twin brings in. What we deal about is, of course, keeping the real and digital worlds in sync. So this is also a very obvious task to do, to have the mirror and the real world being in sync. And this is done by some implementations in there. And we found the digital twin metaphor mostly, of course, in industrial cases, but a lot of consumer-centric IoT scenarios also benefit from it. So in most of the heads, it's really related to industrial IoT, but we don't see it on this side again that much anymore, because it's really very general purpose, and a lot of consumer scenarios also will profit from it. So Eclipse Ditto is really helping to bring these digital twins and the IoT devices together. What is our initial contribution on this? Oh, wrong direction. Okay. I wanted to give one slide again about the industrial IoT. Maybe some of you know it. This is some pictures from the mostly German Industry 4.0 administration shell concepts, which is a very good picture for digital twins. In German, it's called Verwaltungsschale, very strange word. And this is really a kind of an API of a context given around a real asset, and you can really directly name this also a digital twin. So this is kind of a holistic perspective on all the aspects that an asset brings in. This is what we want to do with the digital twins also. Okay, so maybe I hand over to Thomas and he can give you a few more pictures on it.
I try to be a little bit more concrete now in the next few slides. So Eclipse Ditto, like Gerald already told, is our concept of bringing IoT devices and their digital twins together. And what we see as a context view here, having the differentiation between the real world downwards, where the devices live, and the digital world, where the digital representations live. And in between, we see something like Eclipse Sono for doing the device connectivity to those devices. So Eclipse Ditto does not want to provide like an MQTT adapter or Lightfoot M2M adapter. We want to utilize existing Eclipse IoT projects and utilize Eclipse Sono there for integrating, for example, MQTT devices in the real world and communicating with Eclipse Sono via the AMQP 1.0 protocol. And in our world, at our level, Eclipse Ditto wants to target web applications, mobile applications on the left side. So these applications can use the HTTP API of Ditto or can use the WebSocket API in order to get live updates of things pushed into their application. Or on the right side, also backend applications like event processing applications, which also gets like an event stream of changes from real-world devices. Or in the above box twin services, these are functionalities which are not implemented inside Eclipse Ditto, but Eclipse Ditto can route a request from web API, for example, towards this implementation, and this implementation can then perform some code and answer back, and all this is then mediated by Eclipse Ditto, and we also do like a authorization in the Eclipse Ditto project. So only subjects or users from web applications which are allowed to perform an action are really forwarded these actions. And in context of Eclipse IoT, we already mentioned that we will focus on the Hono integration, and we will also utilize Eclipse Vorto at the top for device modeling. So the aspects of such a digital twin can rely on a model which is defined by Vorto. Ditto itself also uses JSON-based representation of things. So we have RESTful JSON APIs. So there are code generators for Vorto out there which generate JSON schema from Vorto schemas, and we will utilize that in order to ensure that these are in some aspects of the digital twins are always in the right format. And yeah, downwards with Hawkbit, I think we will not directly integrate with Hawkbit, but we already talked about it. That Hawkbit maybe will integrate Ditto for storing data related to devices. And yeah, for Eclipse Kapua, we see that they have this data management block inside of Eclipse Kapua, so Eclipse Ditto could be fit in there in order to provide the data management part. Identity provider, we have a JWT-based authentication, so you can use whichever OpenID Connect provider you want to use for authentication. So what's in the initial contribution? 2 weeks ago, or 2.5 weeks ago, we pushed the initial code contribution on GitHub. and since then are polishing it and preparing for the first milestone release of it. Initial contribution consists of 4 microservices from Eclipse Ditto. These are blue ones, and it's a Docker Compose based deployment for getting it up running really fast. And there's a MongoDB started, which is our backend data store for the services. And in front of the gateway, we have an Nginx in order to also deliver a Swagger REST API documentation, and for doing some basic authentication stuff for a minimal setup, getting started quickly. In the initial contribution, we have domain model classes, commands, events, a protocol adapter, which we have a JSON-based protocol, which we talk via the WebSocket in both directions. These Java artifacts are in the contribution. We have Java-based microservices bundled as Docker containers, and we have this runtime dependency to the MongoDB. So what comes next? Also, I already told, we want to make a milestone release in the next days or weeks. We have all CQs type A filled in. And then we want to work on setting up the documentation on GitHub and how we want to work with the documentation in the open source. We have, of course, the documentation which is internal for up to this point, and we want to look at how we can transfer it to open source, and how can we transfer it to Markdown, for example, or for static site generation of documentation. And we will also want to provide some more examples. And project site and logo will be also some of the next steps. And on the technical part, we want to do an optional integration of Eclipse Warto. So if there is a Warto server available and reachable, you can define that parts of your digital twins conform to a Warto model, and this is then enforced with Eclipse Ditto during runtime, that all that the format of these twins are always like it's defined in Eclipse Warto. And then we want to work on the Eclipse Hono bridge for receiving device telemetry in order to update the digital twins. So we prepared a little demo. I hope the demo gods maybe with us. We have this setup here. So again, the digital world, Eclipse Ditto. We have a small JavaScript application, and the real world. Here's a Raspberry Pi with a growth shield on it and 3 growth sensors. It's a temperature sensor, a light sensor, and a buzzer, which can do sound. And that's the setup. And the program language in the JavaScript and in the web application is, of course, JavaScript, and the one on the Raspberry Pi is a Python code running, and the Python code is communicating with the WebSocket with Eclipse Ditto, and the JavaScript API is using the HTTP REST endpoint. So this should move. I guess it doesn't. Yeah, live demo. I have it on another. Okay, live. Okay. So we get some updates from the temperature, humidity sensor, but we don't get, do we? Illuminance, oh no. And yeah, I didn't pray enough for it, yeah. So, okay. First lesson of live demos, don't do live demos. No, it isn't. So, okay. Sorry for that, it didn't work. But what we should have seen here is that we get the sensor values in here. We can change the sampling rate, that the sensor values are updated more frequently. Should get then more frequently in here, and we should have be able to send a message to the Raspberry Pi, which enables the buzzer and disables it again. We will have it on our booth tomorrow, so I think we will get it working on the booth tomorrow if you want to have a look at it. Okay. Okay, thank you. That was. Questions? Yes.
Do you also plan to do implementation of the Industry 4.0 shell, or do you leave this to some other companies or projects?
We're already talking with the standardization guys in this topic, and maybe we will end up that we can be some kind of reference implementation of the specifications there, for example. Yeah. But as it's not fixed yet, we're not really targeting it completely. Yeah.
Are you also talking to the open AAS guys?
We heard about them. We looked at about often there, but we did not talk with them too at the moment. Yeah, they are a spin-off from a university, I think, isn't it? Okay.
What tooling is around? Like, so how do you create the initial kind of model for digital twin? So how do you kind of set it all up?
Yeah, so basically we have a Java model consisting of things and features which represent a thing. But we have really arbitrary payload in it. So we don't do any, we don't say a thing always has like a connection status or has always a manufacturer or something like that. We only have a thing ID which is required, and the rest is optional to the thing. And yeah, starting on that, we have this microservice in which each digital twin is loaded into the memory in the instance. And if there are updates on the digital twin, these are done on memory and directly persisted on database. And if there are only read queries, we can answer all queries from the memory representation of this digital twin. So each digital twin is really an instance in our backend service, and we can scale those out by sharding, so we can add as much cluster shards as we need in order to represent as many digital twins as we need to. Yeah. Back.
So one thing I've seen in the wider industry is that there's two concepts for digital twin. There's the one here, which I think is necessary, and something that's scope. The other is a simulation of a device so that you can test changes on them.
Yeah.
Do you have any? What are your thoughts on that? And do you have any plans on trying to head in that direction?
Yeah. So the simulation part is not directly covered in Eclipse Ditto. We have this. You can, of course, like start a web application or in a Node.js application and simulate a device and its behavior. It would like behave like the real one, and so you can then use the HTTP API in order to query that digital twin as if it were the actual real device. So we have kind of the support for it, but you have to write some code in order to make the simulation logic, do something meaningful like the real thing does.
Maybe one addition to this, and in this case, Eclipse Ditto acts as kind of orchestration engine. Yeah? So it orchestrates other components which do some simulation, for example. Yeah? You plug in these aspects within the representation of a digital twin then. Yeah?
That's one area that I think would be an interesting discussion within the working group is there a way that we can handle simulation of devices within a project?
Question?
Maybe I didn't pay good attention, but you showed microservices and Docker. But what is the technology inside? Is it just plain Java? Or?
It's not plain Java. We're using Akka as a framework. And so Thomas said that all the digital twins are residing in memory. So we have an actor model behind. And all those digital twins are actors in themselves. So each digital twin is an actor in the Akka framework. And we distribute it on a shard or on a cluster. Yeah. And Akka is an actor model framework implementation for Java and Scala. We're targeting at looking at Voto, and Voto itself can import other standards. Yeah, so our intermediate is the Voto model. So we apply to the Voto model, and Voto has the possibility to import different standards. Yeah, sometimes, for example, OMA DM standards, whatever. Yeah.
Which means that you need Moto to have the code generator for the mapping of the things to the Ditto model.
No, you don't need them. You can use them, for example, to do validation and enforcement of types. Yeah. If you don't use it, then you have a generic representation. Then you have put in something and get it out exactly the same way. Yeah. For most aspects, it's a synonym. Yeah. There are some differences, but mostly it's a synonym now as we see it at the moment. Yeah.
Last question. How strong is your dependency to Mongo?
Not that strong. In one area, it's more stronger than the others. For the persistence of the twins, we use Akka, and Akka has a persistence plugin concept, and there's one big implementation which is based on Mongo, but there are other implementations for Cassandra, for example. Yeah. And for the search features, we're currently tied to Mongo. We can change this also, but this is the other part. Yeah. No religious discussions, please. Yeah.
Yeah. We see currently a lot of Cassandra in production.
Yes.
One that Mongo is as well.
It's more a topic about manageability. Yeah. And for, yeah.
We could talk about the ops people.
Yeah. We are the ops people.
All right.